Hi, my name is Parveer here and I'm a grade 12 physics student. I will be discussing some physics concepts related to kite flying. Let's just go right ahead and I hope you guys enjoyed this video. So the first concept I will discuss is the importance of friction during the kite's flight. The friction or drag force is air resistance, which is a huge factor when flying a kite. In kite flying, the friction force and normal force correlate. Due to the kite's shape and trying to get the kite to a higher altitude, the wind must be going against the kite's direction in order for the kite to lift. Too much friction force against the kite might be overwhelming, but too less can cause the kite to prevent flying forwards and upwards. The most ideal wind speed is between 4 to 10 miles per hour, so the wind is helping with a greater normal force and just enough to prevent the kite from stopping or crashing down. Winds that excel 25 miles per hour provide for the worst condition and make it almost impossible for kite flying since the friction force is too overwhelming. And due to the kite's material, it will not be able to move and survive against the wind. This image over here is a free body diagram of a flying kite. If you look at the wind pressure arrow, you can see the relation it has with the drag and lift force. So when there's more air pressure, that means there will be more drag and also more lift. The second concept used in kite flying is tension force. Since kites require the use of a string that can be stretched, there is tension force, which is important when controlling the kite in the air. When the wind exerts force onto the kite, that force can be felt by the person because the force travels through the string. This can also be true vice versa when the person exerts force through the string to change the kite's position and direction. The tension force is most useful to keep the kite in check at a specific position and help guide the kite through a stable flight. Whenever a kite is in stable flight, the forces remain constant and no external net forces are acting on the kite. So for the kite to stay in the same y position, the sum of the y component of the tension force, the force of gravity, and the normal force must equal to 0. And for the kite to stay in the same x position, the sum of the force of friction and the x component of the tension force must also equal to 0. Therefore, the use of tension force is very vital for controlling and manipulating the flight of the kite. And now let's look at the third concept used in kite flying, which is centripetal acceleration. Centripetal acceleration can be used in kite flying when swinging the kite in uniform circular motion. Centripetal acceleration works when the kite remains in constant flight, as it should not change its vertical position but only its horizontal position. Let's look at an example using centripetal acceleration. So a person flying a kite attached to a string that has a horizontal length of 8 meters is swinging a kite in a circular motion. Let's assume that the person holding the string connected to the kite has the same horizontal length all throughout the circular motion. The kite is traveling at constant motion at 6 meters per second. Find the magnitude of centripetal acceleration. As you can see, I identify the radius and speed, and then I use a centripetal acceleration equation, which is v squared divided by r. And I got the magnitude of centripetal acceleration to be 4.5 meters per second squared. A note to take is that centripetal acceleration in kite flying can only really occur if the person flying the kite understands the first two concepts. I hope you guys really enjoyed this video and thank you for watching.